This video corresponds with the fourth lesson in Unit 4A, dealing with solving polynomial equations by factoring. This lesson will follow up what you've learned in the previous three lessons with the different factoring strategies. The difference now is rather than working with expressions, we are now going to work with equations and try to solve for the different values that x could be represented by. So we're going to take a look here at a couple of different problems. First, a problem in which the factors have already been split apart for us, and then we'll take a look at when we have to factor ourselves and solve the equation from there. So if we take a look at the first example I've written here, this is already something that's been pre-factored apart. Here we have the factors x plus 7 times 4x minus 5 equals 0. In a polynomial equation, the goal is to figure out what x is. First things first, we need to make sure that the equation is set equal to 0, which you can see in problem number 1, that's already the case. Second thing we need to do is make sure that the problem is as factored apart as it can be, which again in number 1, you see the two sets of parentheses. That's about as far as we can go with it. So the new step that we're going to add to this, rather than just factoring and leaving it alone, is we're going to take each factor, set it equal to 0, to solve for our two x values. So all I have to do is take this problem number 1 and split it into two smaller problems. So I'm going to take the factor x plus 7, set it equal to 0, take the factor 4x minus 5, set it equal to 0. As long as you recognize that they get split apart like that, all you have to do is some basic equation solving. So we'll subtract 7. One solution is going to be negative 7. And then the other problem's a two-stepper, so we'll add 5 and then divide by 4. And we get our second solution, x is also equal to 5/4. If I plug either of these numbers back into the problem, what will happen is that one of the factors will become 0. 0 times the other factor means it has to equal out 0, which is why both of these solutions, I should say, work out. I'm going to write my answers here where x is a list. So negative 7, 5/4. You can write them out as two separate x values. That's not technically wrong, but the way that you might see it written more frequently is in a list form, especially with problems that technically could have three factors or more. Sometimes that's just a nice way to keep it organized. But that's about as easy as it gets, where you have the problem factored apart already. You are just taking each factor, set it equal to 0, and go solve. Now again, keep in mind, with this strategy here, the only way you can solve these is that if it is equal to 0 once they're factored. They can't be equal to 5 or equal to 10 and do the exact same thing. It just doesn't work out like that, only when it's equal to 0. Now, if you look at problems 2 and 3, you'll notice that they are not necessarily factored apart. The case is number 3, you see it's not even equal to 0. So these problems are going to take a little bit more work in terms of using those factoring strategies. So let's take a look here at number 2. So number 2, first and foremost, it's already set equal to 0. That's a good thing. That's one less step that we're going to have to take. But now I want to take a look at what's on the left side here. It's 11x squared minus 6x. I want to take a look at that. So we need to go through our different factoring strategies and figure out how can I break this down. Well, keep in mind, with any factoring problem, first thing you should always check for is a GCF. If you look in the case of 11x squared negative 6x, we can take an x out. So I'm going to do that. Take an x out, I'll be left with 11x minus 6 equals 0. If I look at what's left in parentheses, 11x minus 6, there's no further GCF, and there's no other factoring strategy we can use. No difference of squares, no trinomial, no diamond, none of that stuff is going to apply. So this is as factored apart as it's going to get. Now, we split the problem apart so we can find our solutions for x. The factor out in front, that x we pulled out, that also gets set equal to 0. So sometimes when you have a GCF, like an x, a 2x, a 6x, whatever the case is, that factor out in front should be set equal to 0. Even though it's not in the parentheses, it's still a factor. We set it equal to 0. And of course, we have our other factor, 11x minus 6 equals 0. So the first one's already solved. X equals 0, that's done. Second factor, again, we do some quick basic equation math. So we add 6, divide by 11. Our other x value is going to be 6/11. So I have two solutions, 0 and 6 out of 11. So again, in this problem, it was already set equal to 0, but we had to go ahead and factor it. And again, any strategy could possibly be used here. Some problems it may only take one strategy to factor it apart. Some might take multiple steps. So again, it just depends on what type of problem you have. Last problem here in number 3 at the bottom. You might notice in this case, if the first step is to have it equal to 0, well, right now it's not equal to 0. That might be a problem. All we have to do is rewrite the equation so that it is equal to 0. So my suggestion in these problems where they're imbalanced like this, where it's not equal to 0, move all the terms that have... There's really 2 options with this. First option is you can move all the terms from the side that has less terms. So like in this case, I'm going to move a 15x and add it to the other side. The other option is if you have, let's say, where one side has just the x squared term, okay? You don't want to make that negative because that means you're going to have to pull out a negative GCF. It's a lot of extra work. Your goal is to make sure your x squared term stays positive. So I would always make sure to kind of shift everything to that side. Now, in this case, again, just to recap, we're going to move the negative 15x over and add it to the other side. Please note, 15x is not a like term. So please do not combine that with 2x squared and magically make that 17x. Not the same thing. Here's what you should get. 2x squared plus 15x plus 7 equals 0. Write it in standard form because it's going to make it easier to use your different factoring strategies. So in this case here, we have 3 terms. First thing we'll check for is a GCF. We cannot take out a GCF in this case because not all the terms have a variable and none of the terms are divisible by the same number. So no GCF in this case. So now we look at what else can we do. It's a trinomial, and it's a trinomial specifically with an a value greater than 1 because we have this 2 out front. So I'm going to go ahead and use, again, you could technically use guess and check for this, but as you've learned in class, you can use the diamond method. So we'll fill in our diamond with our b value and our a times c value. 2 numbers that multiply to 14, add to 15. In this case, it's 14 and 1. So I'm going to go ahead and replace that 15x in the middle with those 2 values I just found. So I'll have 2x squared plus 14x plus 1x plus 7 equals 0. We'll use factor by grouping because we have 4 terms, and we continue our process from there. So in the first group, I can take out a 2x. I'm left with x plus 7. The second group already matches. We already have x plus 7, so just to keep things balanced, I'm going to take out a 1 because it doesn't change anything, but we have to make sure we take something out. My final factors will be x plus 7 because that's the common factor, and my GCFs become the other factor, 2x plus 1. So when I factor this apart correctly, I get x plus 7 times 2x plus 1. Again, we have that equals 0 piece that we're taking along with each step because it is an equation, not just the expression. So now we are going to go ahead and do the same steps that we did up above now that this has been factored. So x plus 7 will equal 0. 2x plus 1 will equal 0. So we get our 2 solutions. So for the first problem, we'd subtract 7. X would be negative 7. For the second problem, we'd subtract 1 and then divide by 2. So we get negative 1/2. So our 2 solutions for this problem would be negative 7 and negative 1/2. So again, this is just building off of the factoring strategies you've learned. Nothing different from what you've gone through in the last 3 lessons. The only difference now is that these are written as equations. So to recap, every one of these problems, if it's an equation, first thing, it must be equal to 0. Second, you factor it as far as you can using any strategy you've learned. Start with GCF, work your way from there. Third step, take your factors, set them equal to 0, use basic equation solving strategies to find your solutions for x. That's how you go ahead and solve polynomial equations by factoring.